Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. Okay, as mentioned before, for this chapter, you should know how to formulate an LP problem and also solve a two-variable LP problem by using the graphical solution method. Okay, so the graphical solution method of two-variable LP problems. So any LP with two variables can be solved graphically, and the graph has the x1 and x2 axis. Look at example 2.2. Solve the following LP problem. So for this problem, the objective function is maximize z equals to 5x1 plus 7x2. First constraint, x1 less than or equals to 6. And second constraint, 2x1 plus 3x2 less than or equals to 19. Third constraint, x1 plus x2 less than or equals to 8. And the lower bound is x1, x2 must be greater or equals to 0. So for the first constraint, x1 less than or equals to 6. So if we draw this constraint on this graph, so here x1 equals to 6. As the sign is less than or equals to, therefore the direction is to the left, right. So don't forget to put the symbols x1 and x2. Okay, second constraint, 2x1 plus 3x2 less than or equals to 19. So for this one, two x1 plus 3x2 equals to 19. So if x1 equals to 0, then x2 equals to 19 over 3. And if x2 equals to 0, then x1 equals to x2 equals to 0, so x1 equals to 19 over 2. So the constraint is here, right? So this is C2. Okay. So to check which direction for this constraint, you need to check by using a reference point. So it is easier to take 0, 0 as the reference point. So reference point here, 0, 0. Okay, so let's say 0, 0, 0, 0. So 2 times 0 plus 3 times 0. So we get left hand side equals to 0, right? So 2, 0 times 3, 0 less than or equals to 19. So 0 is less than or equals to 19. Is it correct? Yes, right. Therefore, this constraint, the direction is to the reference point. Okay. And then third constraint, x1 plus x2 less than or equals to 8. So here, when x1 equals to 0, x2 is equals to 8. When x2 equals to 0, then x1 equals to 8. Okay, so this one is the constraint C3. Okay, so again we take 0, 0 as the reference point. So x1 plus x2 less than or equals to 8. So if we substitute 0, 0, 0 less than or equals to 8. Is this correct? Yes, right. Therefore, the direction is towards the reference point. Okay, and then we have the lower bound. x1 greater or equals to 0. And then x2 greater or equals to 0. So this is the visible region. Okay. So we get the visible region, and then we use the objective function here, z equals to 5x1 plus 7x2 to find the optimal solution. So it is easier to take a number that can be divided by 5 and 7 as the z value. Let's say 35 for this case. So 35 equals to 5x1 plus 7x2. So if x1 equals to 0, then x2 equals to x1 0. So x2 equals to 5, right? So 0.05. And then if x2 equals to 0, if x2 equals to 0, then x1 equals to 7. So another point is 7, 0. So 7, 0 here. And then 0, 5. 0, 5. So somewhere here. Okay. So draw a dotted line. Crossing these 2 points. So this is the Z line. Z line when Z equals to 35. So here Z equals to 35. Okay. For this case, it's maximization problem. So in order to know which direction is maximization, so it is better to draw another line. Let's say z equals to 0, the easiest one. So if z equals to 0, then it should be somewhere here, right? Z equals to 0, so x1 0, x2 0. So the lines should be here, and it must be parallel to z equals to 35. So here z equals to 0. So maximize towards this direction. So z value will be getting bigger and bigger to this direction. So this is the end point in the visible region. If you use a ruler, then move the ruler, you will see that this is the optimal point. So optimal point. And then you need to find x1 equals to what value, x2 equals to what value, and then we can find z value. Okay. So for this case, you need to do a simultaneous equation for constraint. This is constraint 2, right? Yes, constraint 2 and constraint 3. So constraint 2 and constraint 3. 2 constraint 2 and constraint 3. Okay, 2x1 plus 3x2 equals to 19. For constraint 3, x1 plus x2 equals to 8. So if this one we rearrange, so you get x1 equals to 8 minus x2. And then if we substitute into constraint 2, you get 2, 8 minus x2 plus 3x2 equals to 19. So simplify this, you will get x2 equals to, simplify, so we get x2 equals to 3. And then x1 is equals to 8 minus x2, which is 3. So you get x1 equals to 5. So the optimal point is at 5, 3. And then by using the objective function, you will get the value for z. So 5 x1 plus 7 x2, right? Plus 7 x2. So 5 multiplied by 5 plus 7 multiplied by 3. So we get 25 plus 21, which is 46. So this is the solution. Alright. So here you can read the summary of the graphical solution procedure for maximization problems. Right. Okay, let's continue with another exercise. Exercise 2.2. So let us solve the Kinderwood's problem that we have formulated last time. Okay, so maximize z equals to 3x1 plus 2x2 subject to first constraint 2x1 plus x2 less than or equals to 100, x1 plus x2 less than or equals to 80, x1 less than or equals to 40, x1 and x2 must be greater or equals to 0. Okay, so for the first constraint, 2x1 plus x2 equals to 100. Okay, so when x1 equals to 0, then x2 equals to 100. So we get 0.0, 100. Okay, when x2 equals to 0, then x1 equals to, x2 equals to 0, then x1 equals to 50. So 0.50. Okay, so this is for the first constraint. And then constraint 2, x1 plus x2 equals to 80. So when x1 equals to 0, x2 equals to 80. So 0.080. When x2 equals to 0, x1 equals to 80. So 0.80 for the second constraint. And the third constraint, x1 equals to 40. Okay, so if we draw this LP by using a graphical solution method, then we get this region. Okay, for this problem, Therefore, if we draw a straight line, z function, z equals to 3x1 plus 2x2. Okay, let's say z equals to 60. 60 equals to 3x1 plus 2x2. Okay, therefore, when x1 equals to 0, then x2 equals to 0, okay, 30. So, point 0, 30. Another point, when x2 equals to 0, then x1 equals to 20, right? So 20, 0. Okay, so 20, 0 somewhere here. 0, 30 somewhere here. So the z line should be here, right? So this is when z equals to 60. And of course, when this z line passing 0, 0, then the z value is equals to 0. Therefore, for maximization problem, it goes upwards. Okay. So the optimal point is here. This is the optimal point. So in order to find x1 and x2 values, you need to do a simultaneous equation. So for this, between constraint 1 and constraint 2, so right, so 2x1 plus x2 equals to 100 for constraint 1. Constraint 2, x1 plus x2 equals to 80. Okay, therefore, if we minus 1 minus 2, or minus 2, you get x1 plus 0 equals to 20, right? And then x2 equals to x2 equals to 60, because 80 minus 20. So you get x2 equals to 60. So the point is at 2060. So for z value, we substitute into the z function. 3x1 equals to 20. 2 multiplied by 60. So you get 60 plus 120. Therefore, the z value is 180, which is in Ringgit Malaysia. So, as for the conclusion, x1 20, x2 60, z value 180. So, the conclusion is, thus, Kinderwood should produce X1, which is toy trucks, and 60x2, which is toy cars, to get the maximum profit, which equals to RM 180.
There will be no WebEx or Google Meet for this week. Please do all of these questions as your homework. Don't forget to submit your task for this chapter on MyGuru by Friday afternoon. See you next week. Cheers and take care.